Good morning, everybody. Today is October 11th, and we are going to move right on with lesson 3-3, all about slope. So this is actually going to be a review. You did see this in algebra, but since chapter 3 is all about lines, it just makes sense that we cover it again. Okay, so just to review, first of all, slope. That describes the slant of a line. So it tells you not only what direction it's slanted in, but it tells you how much it's slanted. Okay, if you remember the slope formula, we use an m to represent slope. So if you have the slope between 2 points, it is y2 minus y1 over x2 minus x1. You may remember that as rise over run. Okay, same kind of thing. The other piece, and you're not going to see this as much today, but you maybe have seen this phrase, rate of change. Well, that's the same thing as slope. Okay, the only reason that we sometimes refer to it as rate of change is because, like in a word problem situation or something like that, it might make more sense in the story problem for, to say rate of change rather than slope. Okay, so that's the only reason. So those are your slope basics. Now, kind of where we are going to head with this, and here's how it relates to what we've been doing, is when we talk about parallel versus perpendicular, because we've talked a lot about parallel lines, we've talked about perpendicular lines as well. Okay, so let's talk about how their slopes are related. First of all, parallel lines have the same slope. Okay, which kind of makes sense, because if the slope describes the slant of a line, well, wouldn't you want parallel lines to be slanted the same way? Well, yeah, otherwise they're going to intersect. So it kind of makes sense that parallel lines have the same slope. How about perpendicular? Oops. Perpendicular lines have opposite reciprocal slopes. Okay, so opposite reciprocal. So opposite referring to positive or negative. Reciprocal means, well, you flip the fraction, right? So for example, let's say you had 2/3 as a slope, and you want to figure out the opposite reciprocal. Well, opposite would be negative, reciprocal, flip the fraction. Okay? If you had a slope of -5, for example, right? Well, opposite means positive. This is like 5 over 1, so it's going to be positive 1/5 for the opposite reciprocal. So that's how perpendicular slopes are related. All right, and this is kind of going to be the basis of the lesson for today. So let me jump into some examples so you can kind of see what I'm talking about. Here's your first one. Determine whether GH, and that's a line, GH and line RS are parallel, perpendicular, or neither. Notice how I use the symbols to try and keep it a little bit shorter. And then here are the points. G is at 15, -9. H is at 9, -9. R is at -4, -1. And S is at 3, -1. Okay, so what we're going to do is we are going to compare their slopes and see what we get. And if they're the same, we know they're parallel. If they're opposite reciprocals, we know they're perpendicular. If they're no relation whatsoever, then we know it's neither. Okay, so let's practice this. So the slope of GH, all right, y2, -9, minus y1, -9, over x2, 9, minus x1, 15. This is like plus 9. So we get -9 plus 9, that gives us a 0. 9 minus 15, -6. Well, 0 divided by -6, well, that's just 0. Okay, so that's GH. Let's look at RS, slope. So -1 minus -1 over 3 minus -4. Well, -1 minus -1 is like -1 plus 1, so that's a 0 again. 3 minus -4 is like 3 plus 4, so that's 7. Guess what? They both reduce to 0. You always want to look at the reduced answer. Okay? So to me, you know what? These look like they're exactly the same, so it looks like these lines are parallel because they have exactly the same slope. Okay? Let's do another one like this. Okay, so same directions, only I changed the letters here. So determine whether F, G, and H, J are parallel, perpendicular, or neither. And point F is at 1, -3. Point G is at -2, -1. Point H is at 5, 0. And point J is at -3, 10. Okay, so again, we're going to compare the slopes and see what we get. So let's look at the slope for FG to start. Okay, so -1 minus -3 over -2 minus 1. Okay, so -1 minus -3 is like -1 plus 3, so that gives us 2. -2 minus 1, -3. So it looks like -2/3 is what we get for FG. Let's see what we get for HJ. So we have 10 minus 0 over -3 minus 5. All right, so that gives us 10 over -8. If we reduce that, it looks like we get a -5/2. Well, they're not the same, so they're not parallel. They are not opposite reciprocals, so they're not perpendicular. So this is an example of neither. So these are just like two random lines on the coordinate plane. Okay, so that's one type of problem that you're going to see. Another type of problem that you're going to see, this is going to be a graphing one. So this is number 3. Oops, I'm in the wrong. Here we go. Number 3. We want to graph the line with, here's our first one, a slope of 2/3 that contains the point P at 1, 2. Okay, so this is again going back to some algebra. So remember that you always start with the point that you have. Sometimes that's the y-intercept, but in this case it's just another point that's on that line. So 1, 2 is the point that we're going to start with. Now from there we're going to use our slope. It's positive, so we're going to go up 2 to the right 3. So from that point up 2 over 3, and you can keep going. 1, 2, 1, 2, 3. Draw your line. Try and draw it straight. Draw nice long lines. Hopefully yours is straighter than mine. Put arrows on those lines, all that fun stuff. Okay, so that's one kind. Let me do one more like this. I know I'm going fast, but remember, you guys can pause this at any time. So for this one, we want to graph the line that contains point A at 6, 4 and perpendicular to line MN with M at 5, 0 and N at 1, 2. Okay. All right. So it looks like we have a point to start with. So if we start at 6, 4, 1, 2, 3, 4, that's the point that we're going to start with. That's A. We want to use a perpendicular slope. Let's first figure out what the slope of MN is, because then we'll know what the perpendicular one is. Okay, so 2 minus 0 over 1 minus 5. Okay, so this would give us 2 over negative 4. Always reduce, negative 1/2. All right, but it says perpendicular to MN. So we actually want to use positive 2 over 1. We want to use the opposite reciprocal. Now we know which direction to go. It's positive, so we go up, and then we always go to the right. So from our point A, we're going to go up 2 over 1, up 2 over 1. There it is. Okay, so pay attention to whether it's perpendicular or parallel. All right, I have one final example. This one's going to be a little bit different. Here we go. This one says, determine the value of x so that the line containing the point 6, 2 and the point x, negative 1 has a slope of negative 3/7. Okay, so this is an example where we're going to have to work backwards. All right, so we know that the slope is negative 3/7. Let's set up our slope formula using the 2 points. I know there's an x in there, but let's set it up how we normally would. So the slope is negative 1 minus 2 over x minus 6, and we know that that should equal negative 3/7. Okay. Let's simplify. I'm going to simplify the top. Negative 3 over x minus 6 equals negative 3 over 7. Now maybe some of you are good and you can figure out just by looking at it what it is. For the rest of us, you know what you can do whenever you have two fractions that are equal to each other? You can cross multiply. So let's cross multiply. If we multiply here, I'll bring it up here. Negative 21 equals, cross multiply here, negative 3 times x minus 6. Okay, if we distribute, negative 21 equals negative 3x plus 18. Subtract 18, and we get negative 39 equals negative 3x. If we divide, looks like x is 13. There it is. Okay, so you set it up just like you normally would, and then you can work backwards. That's all I got. Hopefully this was a good review of slope for you. I can answer questions on Monday when I return. I hope you all have a fantastic weekend, and I will see you Monday.